All right, we got a little bit more to do at 4.2. We're gonna hit 4.3 and 4.4 today. Let's have a good time and enjoy ourselves. We're almost done. Part B, we'll call it. This is where we were working with exponential functions. Just as a reminder, and we saw what they were, but we didn't do a lot of practice solving equations with them. In fact, I don't know that we did any solving of equations with them. So that's where we're starting today.
Can you put that paper down?
I do want to put that paper down. Better? Oh yeah, now I can see it. Yeah, if I can't change, yeah, Zoom wasn't showing earlier. I don't know why. All right, so example, exponential equations. Let's solve, I think we did this one. I'm going to return to it as a little like primer of what we want to do. The idea is to write the other side in the same form and base as our exponent.
I just have a question. This is part B or because?
It's part B because we did part A, 4.2, we talked about what exponents were. We just didn't do equations yet for it. It's a very short section on 4.2.
Okay.
Let's have a question. So if I want to rewrite 125, oops, I'm getting ahead of the curve here. 125 is 5 cubed. And I can move that to the top by making the exponent negative. When you get it to this form, if the bases match, the bases are equal, the exponents have to be equal. So x equals -3. Next example. Jeez, Jimmy, class just fucking started, bro. Next example. 3 to the x plus 1 equals 9 to the x minus 3. Same premise here. Get the bases to match. I can rewrite this as 3 squared, and then that is to the x minus 3. And so I have 3 to the 2x minus 3. When we have something inside parentheses and an exponent on that, we multiply exponents. And now the bases match, the exponents have to match. X plus 1 equals 2 times x minus 3. We'll distribute. Notice I keep writing down the left side even though I didn't do anything with it. Please do that. If you don't do that, you end up fucking yourself up. And it also makes it really hard to read your shit even when you're right. I'm gonna get all my x's on one side and move my constants to the other. And I'm doing it in a way that my variable ends up positive. 2x minus x is positive x. And this turns into 7, x equals 7. So does that work? We've got 3 to the 7 plus 1. Does that equal 9 to the 7 minus 3? I have 3 to the 8th power equals 9 to the 4th power. I could write this as 3 times 2 times 4, which is 3 squared times 4, which is 9 to the 4th. So yes, it matches. And x equals 7 worked. Gurgle, gurgle. That looks like a fun one. Let's do that one. Anyone need this up longer? Anybody but Jimmy? Let's solve x to the 2/3 equals 25. So I can do this a couple ways. I can write this as the cube root of x squared, or I can have x squared and then that's not what I wanted. I wanted the cube root of x squared. Let's see what we can turn the 25 into. 25 is 5 squared. So this is like x squared to the 1/3. And this is like x to the 1/3 squared. If you don't like working with the fractions all at once, this one is probably the easier one to go with, because then the exponents match. And you get x to the 1/3 equals 5, which is the cube root of x equals 5. So we'll cube both sides, and we get x equals 125. The more direct route is x to the 2/3 equals 5 squared. And I'm gonna raise both sides to the reciprocal of the x's exponent. The 2/3 times 3/2 equals 1. So this is just x to the first power over here. And then 2 times 3/2. If I make that a fraction, I cancel out the 2. I'm just left with 5 cubed over here. And x equals 125, like we had there. You know what's rude? I gotta go home and do sexual harassment training tonight. Not for anything I've done. It's just to blanket everybody that's non-administration, like all the faculty have to do it. And we've had like a month and a half to do it, and I procrastinated. Sounds like a college student. They don't want us hitting on students, imagine that. Or peers. Which is weird because some of the faculty is married, but I'm assuming they met as faculty, but maybe they met as students, who knows? The odds of getting a job at the same school, oh, it happens actually. One of our chemistry teachers is married to someone who they both got hired after they were married. But getting a job at the same school, that's a hard pull. You're competing against a lot of people for a position. All right, so there's one more great equation in this area. The compound interest formula. If you deposit P dollars paying R annual interest, compounded n times a year. After T years, you will have the following. Common times for compounding, if it's compounded daily, n is 365. Monthly, n equals 12. Weekly, n equals 52. Semi-annually is like twice a year. And you could do quarterly is another one. So n equals 4. Take a look at the example. Luis, what kind of interest are we making?
Big number or no?
Take your pick a percentage. I'll let you pick.
Just percentage or
Yeah, like an annual interest rate,
14?
14%. Jimmy, how much are we gonna invest? 500K, look at this motherfucking baller. There better go. How long, how many times are we gonna compound this? It's gonna be monthly, daily, weekly? Daily. Daily. How long should we hold that in there, Eric, without withdrawing any money?
5 years.
5 years. All right, so we got E is P stands for principal. It may seem like an odd thing to use, but that's like your starting deposit. That's our 500K. We chose compounded daily, so n equals 365. R needs to be as a decimal. We don't want a percent. So 14% as a decimal is 0.14. Was chosen as 5 years. So we're going to fill in what we got for A equals P. This one is easy to fucking rush. Try to do too much shit at once and you're just gonna get this shit wrong. So take it slow, do like the inside first. And you could probably get the exponent done at the same time. I recommend doing this in pieces though. 1 plus 0.14 divided by 365. Point 0.00038356. It actually gave it to me as 3.8356 times 10 to the negative 4. But that just means shift the decimal left 4 times. And then 365 times 5, I can do that simultaneously. This is 1,825 out here. So I'm gonna do 1 plus 0.14 divided by 365. And I'm gonna leave it in the calculator with the whole thing because there's some decimals going on here. Like there's a lot of places here. And if n times t is big enough, we might move that needle a lot and those decimal points are gonna map. There's more. So I did this, and this is stored in calculator. So I'm going to do answer raised to the 1,825. And that'll get me what all that equals. $2.013482455. Now I'll multiply that by the 500,000. And we have $1,006,741.228 is what my calculator shows. So what should I write this as?
Just like. You ran it to the nearest dollar or?
We could round to the nearest dollar, but the bank wouldn't. They would round to the nearest penny.
So 23, 123.
%, you get 14% interest, you fucking found a. You ain't getting that kind of interest unless you're dropping like fucking 500K. And I don't even think then. How much was interest? What?
14%.
I don't want the percentage, I want to know how much we made in interest.
Oh. It's about 5. That gives you 6,741.
How do you get that?
We just subtract from the balance.
So to find interest, it's P minus, or A minus P. Because amount equals principal plus interest. So the 506 and $741 and change. What? Right? I'd like fucking 14% interest in 5 years. Yes, please. It basically means you're doubling your money every 5 years. Because we got, notice after we did it, this turned into 2. I wrote a comma there. This is 2.01, which means that interest rate for that amount of time compounded daily doubles or almost a little over doubles every 5 years. So if you did it for like 10 years, you're gonna have 4 times as much. 15 years, you'd be at 8 times as much. 20 years, you'd be at 32 times as much. You could start off with a small amount. Even 1K is up to 32,000. 10K is up to 320,000. 20, that's a, I can put 10K aside for 20 years. Oh, maybe not, I'm getting fucking old. I probably wouldn't be able to spend that money very well in fucking 20 years. And I don't have no kids to leave it to. I could leave it to students, but I don't know if you all are worthy.
Take that 10K.
I meant like student scholarships for future students, not like current students. All right. That's it for that section. Let's do 4.3.
That's it.
Well, we've done a lot already in 4.2. We just hadn't done any practice with functions. 4.3 is on logarithmic functions. So for the following, y is a real number. A and x are greater than 0, and a does not equal 1. If a equals 1, this gets stupid. We write y equals the logarithm base a equals x. This is equivalent to x equals a to the y.
I just have a question. If I already did this, I can like Go
I
ahead.
told you don't have to stay. You just asked this a little
No.
while ago, Ghost
Yeah,
Way.
yeah, but I know, but it's a little bit different than what you did in the video. That's why I'm asking.
Okay, what is it you're asking?
Okay. No, it's fine if I leave. Okay then. Sorry about
Don't you ask a fucking third time. Get it out now. Ask it.
that. Have a good day. Thank you.
It's fucking trolling me. I know it.
How you made it feel bad.
I should have. I should have made him feel worse because I answered that question
Kick me
already.
out. Kick me out.
Oh, he is fucking trolling.
If you don't kick me out, I'm going to jail.
If I don't kick you out, you're going to jail.
I'm going to jail. Scream.
That's extreme. I'm not kicking you out. You gotta fucking make yourself leave. All
Kick me
right,
out.
so this is called the base of the logarithm.
Just kidding. I'm leaving.
Have a good day. Oh, he's gone already. He did leave. That's called the base of the logarithm. That's the base of the exponent. See any connection?
Same shit.
They're both A and they're both the base. So they're both called base. That's one way to, like, you're just gonna have to memorize this equivalency. And I'm showing you how I remember it. The bases are the same. Then the way I remember how log x switches, I remember x is on the other side of the equation. As an exponential. And that tells me where y has to be if x is on the other side from a. If you've got a different way you'd like to memorize it, whatever gets you through like memorizing it, please do. But there's three things and we need to know how they switch from one thing to the other. They are literally equivalent. So let's give you guys a little practice with this. Let's have the log form over here. That's the abbreviation for logarithmic. The log form, and we tend to say EXP for exponential. Let's start with 3 to the 4th equals 81 here. I can give you a few to try to like work through real quick. Take a moment and use that. Let me bring the relationship back down so you can see it all on the same screen at once. None of that. You can knock that shit off now. minute and we'll hit it. In fact, you could even remember it as the y goes to the other side, if you're going from this form. Whatever's next to A goes to the other side. That's probably the easier way to remember it. So A is 3 here, so I'm gonna have log base 3. My 4 goes to the other side of the equation and the 81 comes over. My base for this one is 1/2. The 8 goes to the other side of the equation and the other side comes over as the exponent. Here the base is 10. The exponent goes to the other side. And 1,000 comes over. The base here is 5. The 1/125 goes to the other side, and the -3 comes to the base. Base here is 12. The 1 goes to the other side, and the other side comes over. And here, the base here is 6. The 1 goes to the other side. And the 0 comes over as the exponent. These last two are pretty important. I'll cover them when I give the fun rules of exponents. But they're worth noting the pattern here. If the base is the same thing as the argument, the value of the log is 1. We have a 1 inside the logarithm, the value of the log is 0. Anyone in here need that any longer? All right. Let's look at some examples for equations. So our base here is x, and we need to strip it out. We can convert it to the other form and make it this. The -2 comes to this side as the exponent, and the 16/9 goes to the other side. So this is 1 over x squared. Now, the shorthand of doing this is just flipping them over. That's where we're gonna go. But if you're not comfortable doing the flip both sides, you can always do something you probably learned how to do a long time ago, which is cross multiply. Cross multiply gives us 9 on the left and 16x squared on the right. Then we get x squared by itself by dividing by 16. And we get 9/16 equals x squared. Which is the same thing we have over there by just flipping. Then we want to take the square root. And the square root is going to give us x equals, it's going to be plus or minus square root of 9/16. We saw we can split that up to square root of 9 over square root of 16, which gives us plus or minus 3/4. Logarithms require that base to be positive though. So this forces us to dump the -1 and we just have positive 3/4. What? You got a what? I like what Eric's advice was. Just mark off 10 points for a negative sign. I like this principle. This is why I think that there's a message in it. I bet you pay attention to that shit, didn't you? You pay for the price once. If the price is steep enough, you pay it once and you're like, nope, you will fucking self-monitor yourself from then on. I think I might apply that to my calculus classes in the future. Just fucking bring down the hammer on the first exam.
Sorry, calculus. Come on, Don.
Don't make mistakes.
Watch, I know I'm gonna have it in next semester too. I'm gonna see that.
The next class is Math 54 and I'm not teaching in spring. But I will teach Math 65 in fall if you want to take calculus in fall. It'll be 8 to 10. I think it's on Tuesdays and Thursday mornings here in Tulare. There's other teachers that teach calculus 1. You don't have to take me. But you know, if I find out you're taking someone else, I'm gonna retroactively adjust your grade. Is that the word I could use?
I lose either way,
How is that losing either way? You get me one of the ways.
and then you're gonna implement his strategy.
That's a win.
That's a loss.
No.
You're already.
Eric, show him your test score again.
I already saw it.
He paid that price once and look at it. Fucking tell me like a fraud. Alright, next one. We got shit to do. I can't have as much fun as I like to normally have. Alright, I'm gonna rewrite this. That's my base. The x moves to the other side. The 3/4 is right here. Shit, we got x right away. X is given to us. Just by switching, we have it already. There's 2 ways of looking at this. this is 16 cubed and then the fourth root. Or we take the fourth root of 16 and we cube it. This one's a little bit easier. Here I need a calculator. This is 4 times 4 or 4 squared. And I break these up into 2 squared, 2 squared. This is 2 to the 4th inside there. The fourth root of 2 to the 4th is 2. Then I'm cubing it. So I have x equals 2 cubed, which is x equals 8. I think I know how my wife figures out when I'm doing it in a restaurant. I try not to lean, but I think I do a little bit of a lean, and she knows I'm fucking let it sneak out the side. She knows every time, whether she hears it or not. No, don't do it. I'm like, why? No one's gonna hear it. And if they smell it, it's just gonna make them hungry. She gets mad.
How about, can you push yourself up?
There you go. That'll throw her off. She'll never see that one coming. I like how you think. Okay, we have the x as the base. We had the x as the argument of the logarithm. Now let's do one where the x is on the other side. And until you figure out how to use the change base formula, you're stuck with this. But we can rewrite this as 36 is the base. The square root of 6 goes to the other side, and x comes over as the exponent. We just learned how to solve this. Let's change these up into things where we have matching bases. 36 is 6 squared. And this is square root is 1/2. So this becomes 6 to the 2x equals 6 to the 1/2.
Yeah.
Our bases are equal now, so our exponents will be equal. And I'll multiply both sides by 1/2. And I get x equals 1/4. Let's take a quick 5-minute break. We'll go over how you graph these. And then we'll do the properties. So we're going to look at treating, we said this section was on logarithmic functions. Let's treat it as a function. F of x equals log base a of x. If we look at a graph of this, if we look at log 2, let's look at log 2x. we saw this switches to exponentials. So we're gonna have these as. And it's kind of weird because it's. The whole number ends up being the exponent it spits out, which is the other side. So if I want whole numbers here. These go in as. Exponents. This is. A to the -2. A is 2 here though. So 2 to the -2 is 1/4. You get 1/2. You get 1, 2, and 4. And if I did another one, 8 would be 3. Just gonna do a few of them. So 1, 0 is on all of them. 1/2 -1 is down here. 1/4 -2 is down here. This starts doing this. And we never actually get down to 0. 2 to the 2, 1 is over here. 4, 2 is over here. So this kind of like does some shit like that. And looks like it's not, it never flattens out, but it sure looks like it takes a long time to go up 1 as you get going up. Just a few X. An easier way to remember this, because I just used base 2, but for base A. This point here is A comma 1. And this point here is 1 over A comma -1. And that point is always 1, 0. So that would be for f of x equals log base A of x. A comma 1 and 1 over A comma -1. That's easier to remember than doing it. To me, honestly, than doing this whole fucking chart every time. The domain is what here? What's the range? For what?
Where's the 0 from?
Do we have any negative x values on the graph? No, it actually can't be negative. So it will be the 0. And it can actually be the 0, so we're gonna use parentheses on the 0. The range, however, is doing negative infinity to infinity. Even if it looks like it's flattening out as it gets larger, it's still. That's, you got fucking like bitter beer face right there. It's fucking good shit. Big mouthful of salt. Yep. Never dust off the bag like that on something like peanuts. Chips are different. There's not usually a lot of salt in them, but like fucking nuts, you dust off the bottom. Never dump nuts in your mouth, Jimmy.
Man, I hate you, Doug. I have no comeback for that.
Just talking about what your bear nuts that you were eating.
Could've said the ear nuts. Oh, that doesn't sound any better.
Notice this is increasing everywhere on its domain. And the y-axis, or x equals 0, is a vertical asymptote. Hate you, dog. That's a little rough.
That one sounds right.
Well, my feelings are here, Jimmy.
Yeah, feelings.
I do.
It's a strong word.
I thought so.
Strong with the slang. Guess what stays last?
There's a couple ways to flip this graph over. So if we want to have the graph flipped over. We can have f of x equals negative log base a of x, where a is greater than 1. I should have said this on the previous graph. This graph is for a greater than 1. I think I missed that. That seems pretty fucking important now. Because if a is between 0 and 1, this can be positive out front. But if 0 is less than a, less than 1, we're also going to have this thing flipped over. Either of these, one of these forms has the same domain, same range. The only real change on this one is that it's decreasing everywhere.
Point in between 0 and 1 on the x.
1 over a. So if we have like log base 1/3 of x. We're gonna have 1, we'll have 3, 1/3. And if I plotted it, 9 would be way over here at -2. Maybe I'll elevate the -2 up to make up for my graph being all fucked up looking. Because it should look like it curves like a parabola like there. That's what you get for not drawing the scale, Mr. Jones. Too much sugar. Peppermint mocha frap. I like the peppermint mocha. The frap isn't as good. I'm seeing that now. I had high hopes. I don't think so, and that's why I got it rather than a regular one. Make a really good vanilla bean one. I used to fucking detest vanilla milkshakes. It was like vanilla ice cream was a fucking insult to humanity. As I grew older, I grew to appreciate vanilla as a flavor. I'm like, it's not just a base for toppings. What is? You're good.
Yeah.
You ready for more, Luis? You look like you're having fun. I want you to continue having fun, so we're gonna kick this up a notch, and we're gonna do log base a of x minus h plus k. Guess what this does? Inserting the minus h and plus k. What?
Shifts it.
It's gonna shift it. Which way?
Second.
No.
That's right up down.
What?
That's right up down.
Left, right, up. What the hell?
That right up down.
That's 4 different fucking directions. That's
K is up down.
okay. That's what you meant. Okay. So yeah, this is an up down shift. And it's gonna shift it by HK. So 1, 0 shifts over to H plus 1 comma K. What happens here is like if we have, let's just throw one in here. Let's do log, I don't know, base 2 of x plus 2. Plus 3. We still have the 1, 0, the a comma 1, and the 1 over a comma negative 1. But now we're going to shift all these by h equals negative 2 here and k equals 3. So I'm going to just plot those points, not draw the line. And a here is 2. So this is 2 comma 1. And 1/2 comma negative 1. I would have a point here, here, and here. These all get shifted left negative 2. And they're gonna go up 3, which makes me feel like I should have done a better time drawing this graph. This point is gonna go left 2 and up 3. This point is gonna go left 2 and up 3. And this point is gonna go left 2, up 3. And what happens is x equals 0 was the asymptote. That's the old one. But the asymptote has shifted now to negative 2. So the asymptote is really at x equals 8, h. God, that asymptote's all fucking crooked. So the HK thing continues to do what it's always done. It shifts the entire graph by HK. So this would have been like this. And they all shifted by -2, 3.
Did you get those first sequence? On the green up?
These points,
Yeah.
it's A comma 1 and A was 2. So A comma 1 turns into 2 comma 1. And then we have 1 over A comma -1. And so this is 1/2 comma -1. And it's based on that being A. That make sense? You can always do calculator shit to find the values of it. It's not, I don't know that that's, you're comfortable plotting X and Y coordinates using shit you calculated with a calculator to get Y. Part of it comes from, remember we saw, we had log 12 of 12 equaled 1. So when like the inside log base A, when the inside matches, the right side is 1. So A here is X plus 2. X plus 2 equals 1. So X equals -1 when A equals when X equals, that looks weird. We do this away differently. Because we had X plus 2 here. And this was, that matches. So when X plus 2, when this matches this, we get a value of 1 as a point. So X equals 0. I don't have 0,1 on the graph. Oh, because we've shifted by +3. Then the +0,1 is here, and then we've shifted up 3. I'm not gonna make you graph this long, and to be honest, when you're graphing logs, usually, unless you need detail, that is sufficient. Most people know when they look at it, if you're in like trigonometry or higher, calculus or higher, you know that's the graph of log, and like if you need more detail, you'll figure out, you'll look at like look it up the values and stuff. Like I don't intend on making you graph a log. Now I'll probably make you graph an exponent. But that's just because they show up so goddamn much. I think Luis is ready for some properties of logs. This is the good stuff right here, Luis. This is the take it home and frame it shit. This is fucking magic. You mock me. I don't know that I like being mocked. Watch this. Properties, well, I'll just show how I prove the first property, then we'll make a list. So the first property we're gonna look at is log base A of X times Y equals log base A of X plus log base A of Y. That feels like some magic. Wouldn't you say? Multiplication turns into addition. The hell kind of magic bullshit is this? So to show this, I'm gonna say log base A of X equals M. And log base A of Y equals N. Which means if I rewrite these in their exponential forms, I get A to the M equals X. And A to the N equals Y. So let's take these two and multiply them together. X times Y is A to the M times A to the N. Which is A to the M plus N. And now we're gonna switch back to logarithmic form. A is the base of the log. M plus N goes to the other side. And XY goes inside the log. Is that a fucking dragon on your shirt?
Cool.
Yeah,
Let's go do it.
oh, that's even better. That feels badass. Japanese people come up with something that comes out of the fucking island nation. What do? The fucking monster, they come up with something that fucking rises out of the goddamn sea.
So they saw these I got new.
Why not come up with something that doesn't like might actually seem realistic? Use something that doesn't seem like plausible. A giant sea monster coming out seems fairly fucking plausible. Now, him breathing radiation, that's a fucking stretch. But giant lizard walking out of the fucking ocean? That's not too far from a giant fucking alligator walking out. Right?
Yeah.
All right, what was M and what was N here? We're almost done. Almost done with the proof. M and N were defined up here. So M is log base A of X. And N is log base A of Y. And we have shown that property. Okay. So you guys ready for the list of properties? Yes, you are. Don't shake your head no, you're ready. Your pencil's down, you're not writing, you're not telling me to wait. Properties of logarithms. You do your homework on these, by the time you're done with the homework, you should be okay. We just showed one of them, log base A of xy equals log base A of x plus log base A of y. Multiply inside turns to addition outside. Assholes named the properties. I'm not naming them. I've never used these names before. I'm not gonna do it. So if I have x over y, I have divide inside. Guess what that leads to outside?
Log A X, log A Y.
Close, but not quite. Multiply turned to addition, what
Oh, log A x minus log A one.
turns into subtraction, yeah. This is actually highly related to the next law, or next rule. Is log base A of x to the r equals r times log base A of x. So you can move the exponent out as a multiplier. Log base A of 1 is 0. And log base A of A is 1. All right, you guys ready to practice applying these? See how many I can keep on the screen and still write. A lot. Let's move over here. Fucking thing froze. So like rewrite in another form. We'll start off, we'll expand them first. So like example A, we're gonna do log base 7 of 8 times 6. If I expand that, I get log base 7 of 8 plus log base 7 of 6. Log base 6 of 12 over 5. What should I get on this one?
Log 6, 12 minus log 5.
Look at you, who thought this all hard, and you're like spitting it out like it's fucking easy.
It's easy to remember that.
Well, good, you're gonna enjoy this portion of the final. All right, you think you're fucking Billy Badass?
So these.
What's wrong with Billy Badass? That's a fucking great name. It's got alliteration. The only thing in Jimmy, if I'm gonna go with something with a J, I can't say it in this class. Well, this is log base 2 of 9 to the 1/3. So this is 1/3 log base 2 of 9. Log base A of the fifth root of R cubed. What can I rewrite that inside as? What's the exponent gonna be?
R to 3/5.
3/5 is correct. Look at me saying it like I'm all fucking surprised. You agree?
Yeah.
Awesome. Jimmy, what's the next part? Not yet. What do we do with the exponents? It's the exponent roll out.
3/5 log.
We pull the exponent out front as a multiplier. That's right. That's it. That's fucking it. All right, let's do one big one to rule them all. This is some shit Hefe will throw at the fucking test. This seems like something. Looks like something I want to do. R cubed S squared T to the, I don't know, fourth. Over U to the, we'll say U squared. V, let's use W because V looks a little like U. W to the, just W. Just do W. MFR. That's probably a little bit more than I want to do on the exam. I know I'll fucking tank some grades with this shit. So I could rewrite the inside as, I'm just gonna call it smiley face for now, to the 1/m. Because I don't want to rewrite all that shit again. I fucking made the problem bigger than I want to fucking rewrite. So smiley face is the fucking inside. So we could pull the 1/m out front. And now I'll put them back in. This madness just got real. This is fucking insanity. I've got 1/m equals log A of R cubed. Not equals, times. Plus log A of S squared. Plus log A of T to the fourth. Plus log minus log A of U squared minus log A of W. Finally, we pull the exponents down. And I got 3 log A of R plus 2 log A of S plus 4 log A of T minus 2 log A of U minus log A of W. We'll do a couple more going the other direction. So here we want to collapse. Fucking skittish eyes. It's embarrassment is what it was. Should have been. All right, how can I put these together? First off, can I put these together? Yes, the way you can put them together, make sure that the bases match. The bases don't match, you can't put them together. Bases must match. So I can put these together as one big thing. X is, this one has got a positive thing. We're subtracting the y, so the y subtraction turns into division. And we're multiplying by, oh, I wrote z. That was an x. The z comes down. Z is positive, so it'll be on top.
It would be xz, not x plus z.
Correct. Multiplication on the inside, addition on the outside. It's tricky, huh? You just gotta do a few and you get used to it. Sometimes they make it a little bit harder. 4 log base b of r minus 5 log base b of s. To put these together, they have to have a coefficient of 1. So to proceed, we need to move that multiplier outside, inside as an exponent. I'm realizing using s and 5 together is fucking stupid. So put them together, log base b of r to the 4th power over s to the 5th power. All right, so important to note, exponents and logs are inverses. And recall the way we showed, you could show that was f of g of x equals x, or g of f of x equals x. The way we end up having these put together, we can have 2 formats that we'll see, or things that you can work with. A to the log ax, where log ax is like the exponent for a is just x. The other one just falls out of our rules of exponential is pretty easy. If we have log base a of a to the x. You just move the x down in front. That equals x times log base a of a. But we already said that's 1. So log base a of a to the x is just x. How might you use this? I'm gonna go back and put up the problem we already had. Recall we did earlier log base 16 of x. And we found out this meant x equals 8. We're gonna do this a different method. So doing this a different method. If I want to get x out of the logarithm, I can treat each of these as exponents for base 16. So I'm going to have 16 log to the 16x equals 16 to the 3/4. I'm taking advantage of this first one up here.
What does it say?
16 log base 16,
No,
treat as exponent for 16.
the x, don't have the row.
8. We did that earlier on a previous problem. All right, this just collapses down into an x. And this is the 4th root of 16 cubed. Or if you just put it in a calculator that lets you use like fractional exponents, it'll just spit out 8 in a calculator. And speaking of calculators, this is what we're going to need to use on the next part.
Here's those treat as exponent for 16.
So we're going to treat each side as an exponent for 16.
So that's the 16 is to the log 16 base x.
Yeah, this is an exponent for the 16.
Okay.
That's an exponent for the 16. And we'll do some examples of that in on Monday. We don't have class on Wednesday next week. Get out Thanksgiving early. Now I'm not, if you don't show up on Monday, I'm not gonna be surprised. If you don't show up on Monday, you need to watch the video for 4.5 and 4.6. Let's do a little bit more. I'm gonna let's do 4.4. If you literally in like 6 minutes, if you want to see problems of these worked out, check out a previous semester's video. I'll put up a link to it. This has our change of base formula and a couple other things. So on a calculator, you only have 2 versions of the log button. calculator has log and it has ln. That is an L. But it doesn't look like an L, it's usually a lowercase l. This is the common log. And it means log base 10. This is the natural log. And it means log base E. And we don't ever write log base E after really introducing the topic. ln always just means log base E. So if you want to find this shit in a calculator, like log base, if you had something like, oh, this is just log, and this is just ln. So if you guys see something like log 100, you can hit log 100 equals, and it should spit out 2, I believe. If you have log base E of, I don't know, 7, you can put in ln 7 equals. I have no idea what natural log 7 equals. I'm not even gonna fake it. No idea. I bet it's a little under 2, maybe 1.8. Now I want to know. In fact, I should have it down just so you can like make sure you know how to use the calculator. I'm getting 1.9459. So this one is used in chemistry a lot with the pH system. pH of a solution is defined as the negative log, common log of H3O plus, which is the concentration of hydronium ions in moles per liter. There's some stuff worked out with this in video. And I'll probably do some of these on Monday. Volume of sound goes off of this. D is for decibels. And it's 10 log of I over IO. Where IO is the faintest sound you can hear. Or the intensity of it. Log base E shows up in population growth and decay models. Carbon dating, radioactive decay. I got one more formula to give you, and it's trivial. But what about everything else? What if we don't have a base that we like? What if, like, we got log base 10 and log base E, what if I want to throw something else in a fucking calculator? How do we get the other shit in a calculator? Does anyone need this up longer? So for every other base, log base A of X, you can do log X over log A. Or you can do natural log of X over natural log of A. That's a fucking magic right there. Well, let me give you some so that you can throw it into a calculator so you can see what it looks like. Log base 4 of 20. No matter which one you choose, log 20 over log 4 or natural log 20 over natural log 4, you should get approximately 2.1610. And if you do log base 2 of 0.7, this is log of 0.7 over log 2. Or natural log of 0.7 over natural log of 2. And you should get approximately negative 0.5146. This stuff can be used, one of them is like modeling diversity of species. This is crazy. I don't have a good example of that really. They got it listed, but. So like carbon dating, aging stuff with archaeology stuff. I got a few examples I'll go over on Monday. It's kind of neat, some of the stuff, how it works. Other than that, get the fuck out. Have a good weekend. The change of base isn't too bad, right? Now 4.4 is like examples using this stuff. And I'll do those or if you're working on it over the weekend, you can always watch one of the videos.